Assalamualaikum. My name is binti student ID 2023-851472, and I'm from group JCDCS 1432D.
Hi, Assalamualaikum. My name is binti student ID 2023-640728 from class JCDCS 1432D.
Hi, Assalamualaikum. My name is binti Mohammad, student ID 2023457618 for class JCDCS 1432D.
Hi, Assalamualaikum. My name is binti Mohammad, student ID 2023809832, and I'm from JCDCS 1432D. Thank you.
What is differentiation? Differentiation is a method of finding the derivative or the rate of change of a function. We use differentiation to determine the maximum and minimum values of a particular functions. To solve differentiation problem, there are three techniques that we can apply, which is derivative of sum difference, derivative of a product function, which is product rule, and lastly, derivative of rational function, which is quotient rule. Next, I'll be guiding you about application of differentiation in related rates. In differential calculus, related rates is a problem that involves two or more variables that change at the same time, possibly at the different rates. Now, let's go to the objective of the related rates. Why we use related rates? In a related rates problem, the idea is to compute the rate of change of one quantity in terms of the rate of change of another quantity, which may be more easily measured. The procedure is to find an equation that relates the two quantities and then use the chain rule method or implicit method.
Now we move on to the problem statement. Two sides of triangle are 7 cm and 8 cm in length, and the angle between them is increasing at the rate of 0.04 rads. Find the rate at which the area of triangle is increasing when the angle is pi/6 rad.
Next, I will continue the presentation with the steps to solve the problem. Here, I have divided the solving method to 3 steps so we can see clearer on what we're supposed to do in each steps. For the first step, we just have to highlight or jot down all the necessary values or points from the question. So, based on the question, given that d theta over dt is equal 0.04, and we have to find the rate of change for the area of triangle, which is dA over dt when theta is equal pi/6. Besides that, we were also given two sides of the triangle with the length of 7 and 8 cm. Then, we just have to rewrite the equation as dA over dt equal dA over d theta times d theta over dt. As we can see from the question, there is no any informations in the term of area, so here we are ought to recall a bit on the area of triangle. Next, the second step is to apply the most suitable formula to find the area of triangle. As I mentioned earlier, there are two sides length given in the question, so for this problem, the most suitable formula we can implement is A equal 1/2 AB sin C. Then, we will substitute the value of each sides in the variable a and b and substitute c as theta in the formula. So, we will get the equation of A equal 28 sine theta. Next, we will differentiate the equation. Here, 28 is a constant, so we just have to differentiate sine theta to cos theta as shown in the formula. Then, we will get an equation of dA over d theta equal 28 cos theta. Lastly, it will just be a simple step because we just need to substitute all the values obtained in our very first equation. After we fill out all the values and do calculation, the final answer will be 0.9699 cm square as negative 1.
Last but not least, conclusion for our assignment. In related rates problems, the key conclusion is that the rates at which related quantities change are related to each other. By using the chain rule and differentiating an equation that connects the variables with respect to time, we can determine the rate of change of one quantity based on the known rates of change of other quantities. This approach is essential in solving real-world problems where multiple quantities vary simultaneously and their relationships must be understood to find solutions. For instance, in the specific problem of finding the rate at which the area of a triangle is increasing when the angle theta is pi over 6 radians, we determine that this rate is approximately 0.97 square centimeters per second.